This is Elizabeth Bergman presenting on addition. I was interested in researching addition because it was one of the first mathematical skills we teach in kindergarten. Teaching kindergarten, we have standards like in math 0.12, where students demonstrate the meaning of addition with whole numbers and computing accurately, and completing that to show how they're doing it. I notice so often that my advanced students might already have facts memorized, like 2 plus 2 is 4, but not being able to explain or show why that fact is true. I wanted to research the transitioning of addition for younger students. The article that assisted in my research was titled Early Addition. It is in the cards by Sally Mauro. The article focuses on younger students, specifically in preschool and kindergarten. At this age, many students are starting to identify numbers first visually and then numerically. They learn the numbers first by counting dots, dashes, pecks, and items, then move on to identifying certain numbers. It focuses on accurately and the difficulty when numbers like 6 and 9 look alike. Even though students can identify numbers, they may not be able to count them or combine them together. An example is if one dice says 2 and one dice says 5, they can identify it, but when the student goes to count on, they say 1, 2, and then move on to the next dice saying 5 because the total number of 5 on the dice was shown. Many preschool students struggle to add on the second number. We should help our students focus on counting pips on the dice all together and then focusing on the actual definition of addition. At the time of school entry, children's math skills are more predictively than reading skills of later overall academic success. Therefore, there's been lots of research done on early mathematical education strategies. Two ideas presented by Camies in the article Seminal Work in 1982 have shown research to be highly effective in helping children develop math understanding by integrating math throughout the curriculum and using small group for games to help the students understand the facts. We want students to have a conceptual understanding in all areas of curriculum and fade away from memorizing quick facts. We can help them learn addition at a young age by letting them play board games, play them with a friend, and helping them understand not only how to count the objects on a spinner or a dice, but moving forward or moving back. Class votes help students to count on how many students voted for certain categories and compare numbers, making a number bigger or smaller. Playing cards help our students count the number of symbols and identifying them numerically. Once a student has mastered the identity of a certain number, they can move forward onto two numbers together. The last the students can learn by representing quantities is drawing pictures and representing numerals and miracles themselves. Students must progress into addition first by counting all items together either with their fingers or counting certain items. Shortcut sums are where students can count the whole number instead of two groups separately, and last counting on to where they extend the first number. A common misconception that researchers are making is that students are actually hindered by learning numerical symbols such as addition and subtraction because it is the only surface level thing that they'll be able to understand. The student can't extend an algorithm or identify the relationship. But in our book titled Teaching Student-Centered Mathematics, we see on page 84 the direct instruction that Mr. Logan shows his students that 3 plus 5 and 5 plus 3 are both 8. We want our students to overcome the misconception of helping them represent why the math problem is true and showing them why. It is important we don't just emphasize flashcards and timed tests that don't help our students understand the math knowledge. Instead of memorizing, we want our students to learn counting strategies where they can count physical objects such as pictures, and then use reasoning strategies to show why 5 plus 6 is 11, because they already know 5 plus 5 is 10, and 6 is 1 more, knowing that 5 plus 6, adding 1 more would be 11. Last comes mastery, and we can expect our students to get there at different times because of different facts, and then they can become quick and automatic from there. The article in the book reminded me both of the first article we read, Simply Fast and Accurate, I Think Not, by Linda Gojak, that we read in week 2. We see similarities that is not about meaningful quick facts, but memorizing quick facts, but have our students to show meaning, show their work, and learn the reasoning behind why the facts stand true. A student can work through a worksheet in less than a minute. That's great, but without being able to explain what it means for 5 plus 4 equals 9, and flipping that to 4 plus 5 also 9, we've missed our mark as teachers. The article that I read can pertain to all teachers in helping them focus on why addition is not only important at a young age, but how it should be learned. We want our students to first be able to identify basic numbers, count numbers, showing one-to-one correspondence, counting on from one basic number and extending the second number, and last, being able to see patterns in relationships, being able to be informed and identify and make addition problems themselves. It's important that we help our students learn math and number concepts from this very young age. I will use this information in my own classroom and focusing first on identifying numbers and then having the students move on from there. I before have moved into addition because it's set in our curriculum without realizing the set importance first of identifying numbers separately. I don't want to focus on students memorizing facts anymore, but want to encourage math talks where students can identify why the facts are true and discuss with one another what they've learned about the addition problem. This article in class has helped me become a better math teacher.